Tom Strong from Elliston Construction. This is the second time I've been to this class to give a presentation. Bob has me come in and fill in while he's away, I guess. So I look after the Building Information Modeling Virtual Construction Group at Elliston. We're about 30 people across the company. I don't know if you're familiar with the company. We do about $3.5 billion in construction a year. About 2,000 employees, offices all over Canada, some offices in the Middle East. And we started this initiative here. We set up a virtual construction department after we finished the Art Gallery of Ontario, which is just down the street. If you haven't had a chance to check it out, go check it out. I think it's free to students on Wednesday nights. Anyways, I've got about 45 minutes to dazzle you, hopefully, with some neat stuff and talk to you about where we think that technology is going with construction. And I think it's pretty relevant to the career path that you've chosen because it's becoming more and more prominent in the use of this technology in the industry. So let's get into it. Ask me questions as we go if you want. If you have questions, just shout it out or raise your hand. I'll stop it. So, as a general contractor, the main thing we do is address risk, right? A client has to build a $100 million hospital. They've never done that before, obviously, and they have to hire all the subcontractors and manage all the risk. Is the design going to be to code, or is it going to be built on time? Is it going to be built on budget? And that's essentially what we do is we manage risk. So the more time we have to deal with that risk, the more planning we can do and the more we can perfect things before we get to the actual job site and install systems and hire subcontractors and spend money. So essentially risk is things that we don't have time to solve. There's always a certain amount of risk that we go forward with into construction. And what we're trying to do with new technologies and things that we're doing inside the company is try to improve the way we manage risk and address it directly and try to do the best job possible and do more with less, essentially. So the construction industry and the design engineering industry is evolving very rapidly right now. The automotive, aerospace industries have been using CATIA and SolidWorks and other parametric modelers for years to develop the entire airplane or car fully in 3D so that they can move that into a manufacturing process and have certainty over exactly what they're going to do. And they test that engineering in the 3D environment, and they make sure that everything fits together before they go and build that first car or whatever the case is. The architectural engineering construction industry has kind of evolved a little bit slower. The technology is catching up. It's a much more complicated problem because you're not building a product that's going to be produced over and over and over again. You're producing a building, you're doing it once generally. So it's the value proposition of spending all this time to plan to the nth degree isn't necessarily there all the time, right? Because you can go back and touch up some drywall or paint or whatever the case is. But the technology recently, like with Autodesk is pushing Revit, there's ArchiCAD, there's Bentley, there's a number of different systems out there that are designed for what we do so that we can use 3D modeling to perfect what we're going to do and engineer what we do before we go and actually go build it. So we're kind of taking a cue from the manufacturing world, right? We're starting to think that way. How can we manufacture the building? So it was this image right here is taken from the Sick Kids Hospital on Bay Street, the building that we're building right now. And that's the interstitial space above the laboratory space. So lots of complicated systems in there. And it used to be that you'd hire skilled labor, they'd come to the job site with raw material and they'd cut that material in suit and they'd install it. And now we're thinking differently. We want to predetermine exactly what we're going to do 100% and prefabricate it if we can, bring it to the job site in a very planned way and install it in a very systematic way. So that's the main change. So building information modeling. So I mentioned some of the stuff out there, but it's different from 3D modeling in that every single component that goes into the model contains data. And the whole model acts as a database. So you can query the database and extract information from it. So each model can have endless amounts of data, and there's a lot of debate over how that data should be structured right now. But out of the box, you can do some pretty fantastic things that you can't do with CAD. So it gives you a lot of advantages over a typical CAD process to work to produce your documentation. The big advantage is that you can work in 3D and all your documentation is fully coordinated. And because the system, all your sections, your elevations, your drawings, and the 3D model are one and the same. If you say pull a door out of the 3D model, it pulls it out of the door schedule, it pulls it out of the section, it pulls it out of the elevation, and it allows you as an architect or engineer to keep your documentation fully coordinated, which is risk from your perspective as you design, right? So the main important thing that you got to understand is that the model and the drawings are one and the same, and that goes for the softwares that the subtrades use as well. So by virtue of coordinating that 3D model, we're coordinating all the 2D documentation, all the paper that's going to be produced, and that paper ultimately is what goes to the job site for the subtrades to use to lay out systems and install systems. So here's just a quick example. Can you see that okay? Should we kill the light on the front here?
Yeah, so
Which is which?
go ahead, try on there.
That's better. So that's the Waypoint Mental Health Hospital up in Penetanguishene, Ontario. It's about a $250 million kind of mental hospital. And we've got multiple players producing 3D content. And what my department does is we deploy a specialist to participate in that job, to work on the job site, to integrate all this 3D information that's emerging from all these different companies and bring it together into one location to make sure that it all fits and works. And the information is constantly evolving, and there's multiple companies that are producing information and sharing information, so it's got to be managed. And essentially when you stick all that work together in the same location, you can determine whether it's going to work or not work. It's very simple, right? So then we mitigate all those issues, track them, deal with them before we go to the job site. So the process kind of looks like this. During design, you have each one of your consultants producing a 3D model, and those models are integrated together at the design stage, so you can see the structural steel and the ductwork and the architectural systems all in the same location, so you can make sure that as the design evolves, that it's working, right? And then we, as a general contractor, we can take that model, we can quantify it, we can look at it from a logistics standpoint to make sure that it's on budget or that it's constructible, etc. When we move into construction, we take that sort of base model that represents the design intent that might be at a low level of detail, and we break out all the relevant bits and feed that to our subcontractor. So we would take that design structural steel model and give that to our structural steel subtrade, who's going to work in a different software to engineer all the connections and actually produce the shop drawings and working drawings that they'll go and fabricate the steel from. So the level of detail increases as we go, and we'll collect that model from the subtrade, and we'll collect the ductwork model from the subtrade and the piping model, etc., and stick that all together in the same location, so we're constantly checking to make sure that all this work's going to fit and work before it hits the job site. And then the third part of that is facilities management. So as all that information is emerging that represents exactly what's going to be built in the field, we can integrate all that information together and then hand that to the client at the end of the project so they can use that for the whole life of the project. Because you build a hospital, it's going to be there for 40 to 100 years, and the guys that are running the building need access to that data for renovations or just keeping track of all the information on the project. So the challenge is, yeah, go ahead.
With the suppliers, like structural steel or duct pipes, all those sorts of things, are they catching on to this and becoming literate in these 3D models and all that?
Yeah, it's kind of a mix. It's kind of mixed. Like certain regions, like Toronto, the subtrades they've been around for a long time. They're pretty sophisticated. They're established. And across the country, we're dealing with some subtrades that have a pickup truck and a shovel, right?
Yeah.
They don't even have a cell phone or a fax machine.
Yeah.
So we have to figure out the best strategy to make it work that's appropriate to each project.
Right.
But definitely the major subcontractors, the structural steel, mechanical, electrical, curtain wall subs that are dealing with like big contracts, they have a CAD department and they're bringing that CAD department into the 3D world, whatever software they want to use that's appropriate for what they do. But like structural steel, they've been there for a long time, because it just makes sense for their business, right? You don't want to be manipulating structural steel connections in the field. You want to build it in a factory and deliver it to job site and hold it in place.
Sure.
So it makes sense to have the best systems possible. So yeah, the subtrades, what we're doing as a general contractor is we're specifying it when we tender the job. We say, here, you must build this structural steel, and you must produce a model and submit it to us for review. So it's part of their scope of work, so they have to do it. But we kind of do that selectively when it's appropriate on projects, right? Because we need a competitive process. If we can't get a competitive process, there's no subs that can produce 3D models. We have to kind of negotiate and try to get them more sophisticated. Right? Anyway, so the challenge with this process is that all the subtrades are using different softwares. Like in the models we get from the consultants are typically in Revit, and then we move that, we export the Revit models and we bring it into Navisworks, and then we get all these different formats from all these different players, and we need to make sure that all this information is going to dovetail. All right, so we need origin points, we need some standards, we need some rules, that all this information can come together. And at the end of the day, we need to hand this information off to the client in a format that they want for their purposes. And it's kind of a new deliverable, and some clients that are asking for it in a very sort of vague way, and where you have to work with them to give them exactly what they want. In some cases, the clients are pretty sophisticated and they want something very particular, and we need to manage that through the process. So the value proposition is pretty simple. We want to reduce waste and rework, and obviously increase profitability. So if you're a sub-trade, you want to do things once, you want to do it right, you want to maximize your profit. And then if you're an owner, you want to reduce changes and delays, and you want to make sure there's no cost escalations. You want cost certainty. When you go to build that hospital, you don't want it to cost $120 million. You want it to be on budget at $100 million, or whatever the case is. Here's another kind of quick example of data center. So this is an example where we have, again, many different companies contributing different content at different stages, and we're managing that the information as it emerges. So we've got underground conduit servicing all these servers. We've got a structural steel model that shows all the steel and sprinkler systems and mechanical systems. And each one of these disciplines is built by a separate company, and then we're integrating that information all together, checking it on a regular basis. We're reporting the issues, they're updating their models, they're resubmitting the models to us, and we're reintegrating it to make sure that all of this content will be perfect before it hits the job site. So obviously some big advantages to working this way. And then the client has this model long-term. They can actually link this model to their data. So if they wanted to store, say, a cut sheet or a set of shop drawings regarding the air handling unit, you can link that information right to the object in the 3D model. And then if you're looking for the information 10 years from now, you click on the object and you can retrieve the information. So from an industry perspective, well, my department's pretty big. There's other general contractors that have started up, and they're kind of pushing the subtrades to evolve. Certain owners are pretty proactive. Certain consultants have realized the advantage of working with the systems, and they're pushing their offices to evolve, and some of them are way out in front. And in some cases, they're way behind. So it's still kind of a mixed bag, and obviously there's a big demand for students or people coming out of school right now that know these systems, because all the consultants are kind of trying to switch off of CAD systems and move on to BIM systems. There are some standards starting to emerge, like a BIM execution plan is a pretty standardized document now, where you're seeing different versions of it, but the concept's always the same, where you get all of the different consultants together and all the different players together to make sure that all the information that's going to be produced can work together, dovetail together, and that's the point of the execution plan. And then owners are starting to figure out how they can use this information long term, and the software companies are starting to catch up as well, because there are some big players in the facilities management software side that are starting to integrate and make their softwares work with the 3D information that's available. And of course, it's on the rise, like everyone's adapting these systems. So from a schedule perspective, typical construction, we get the tender documents, we go to tender, we hire subcontractors, we award the work. They start producing their documents for submission. They start fabricating their material. They deliver that to the job site, and they install. And the trouble with that approach is that we find the problems when they're installing. So they get to the job site with this material, with this plan, and it doesn't fit, because we're never able to fully integrate all this work together and find the issues. So these the requests for information, the RFIs, emerge while we're installing, and that slows construction down. It costs the owner money. It costs the sub-trades money, because they have all this labor on the job site now, standing around, and they have to reallocate it somewhere else. They might have set up a scaffolding system to access a certain spot. Now that has to be dismantled because we can't do that work yet. So there's cost escalations. So what we're trying to do is introduce this new stage where the subtrades produce 3D models, we collect those models, we integrate them, we find the issues up front, we be proactive, and then when we go to install, everything just works. It's a smooth process. So that's kind of from a schedule perspective, what we're trying to do. And of course, if we can move that coordination stage even further up front and have more integration between the general contractor and the subtrades during the design phase, that's even more to the owner's advantage. So typical lump sum contract, this is historically how construction was always done. You know, the architects and consultants kind of work in a box, they produce a set of documents, the owner issues that documents out, the general contractor comes in, gives a lump sum price to build based on those documents, and it's a very adversarial process. The low guy wins, we go forward. If there's issues, the owner has to pay for extra issues and becomes a bit of a battle. So it's not very collaborative. But it is possible to implement BIM in this kind of situation, but we're finding that that as the industry matures, the owners realize that they get more value for their dollar having a less adversarial approach. So we're seeing more and more, say, design-build contracts where the owner hires the general contractor, or sometimes it's consultant-led, and there's a consortium between the general contractor and the designers, and they work together to come up with the design together, and then they hire the subtrades. So it's a much more collaborative process.
How would BIM work if it wasn't a design-build project?
It's,
I mean,
yeah.
if an owner gives you a drawing, and that's like he hires a consultant, and the consulting firm produces it.
Yeah.
Isn't it a done deal then?
Well, yes and no. Like sometimes with lump sum, it's very, the general contractor can't ask for what they need from the consultant. So they may produce models, but those models, they may not share them because they feel like there's risk or liability in sharing 3D information because the contract has to be based on the paper. So if they do feel comfortable sharing the models are provided for reference only, and they're not typically organized to work well with all the other 3D information that's going to emerge. And the trouble from the general contractor's perspective is that when we go to tender the work in a lump sum scenario, we're getting a price based on the documents from subtrades, and we usually pick the lowest price.
Yeah.
And if it's not specified in the documents that that subcontractor has to produce a 3D model, we can't ask for it because then his price will increase because he'll perceive that it's extra work, and then we're not the low guy and we don't win the job. So it's kind of a backwards process. So if we do win the job, what we typically do is we go and we can negotiate with the subs and say, hey, you're the low guy, we want to hire you. By the way, we want you to produce models. Do you produce models? We want to run this process
do you ask
to
the
manage
owner
risk.
as well?
Pardon me?
Do you ask the owner as well to produce everything?
If we can get our hands on the information, we want it, right, essentially, even if it's just for reference only, which it typically is. But it's still useful for us. And you know, we want the subtrades to be successful. We want them to meet their bid profit. So we want to help them and make the sort of best environment for them to work and make sure that they're managing their risk. But you know, the problem with lump sum is that if there is a problem, the owner has to foot the bill typically, right? So there's a reverse incentive to do the best job possible. Sometimes the subtrades say they know that there's a problem and they don't tell anyone, and then they and then they go and they wait to tell everyone about the problem so they can get a change order to fix it. So they'll put in a low price knowing that they're going to get paid on the backside to fix a problem. So there is a reverse incentive to work together to do the best jobs. And that's why the industry is moving away from those types of contracts. But you still see it in certain pockets. But definitely design build is an alternative to that. There's also construction management. So construction management, the general contractor is acting as more of a consultant to the owner, and we're working on their behalf to make sure the job goes as smooth as possible. In this scenario, the owner actually holds the paper, they hold the contracts with the subtrades. This works well as long as the design team is on board. Like the owner has to push the design team to produce 3D content because we're not in the driver's seat. With design build, we can actually pick the consultant we want to work with and we get the best out of them. But in this case, it's negotiated with the consultants to get them on board. But it's getting easier, obviously. And then AFP, or this is the P3 model, so public-private partnership. This is where the owner produces basically a spec of the building they want, and it's basically a design build, except we also have the facilities management risk and the financial risk with getting the money to pay for the hospital, whatever the case is. In this scenario, a lot of times we get the consultants to work for the subtrades, so that compartmentalizing that team, so they have to work together and we're not in the middle of it. And then a new kind of contract that's emerging is integrated project delivery, IPD, which is kind of like in the States. There's a lot of this taking place where you actually build a consortium, and the major players who are holding all the risk, they have a shared pain, shared gain relationship where they're actually all drawing from the same profit pool. So now they have an incentive financially to work together to maximize profits. So it's the opposite of like a lump sum, where they have to work together to make the two be as profitable as possible and meet their targets. So one of the ways that we're using 3D modeling is that we're using like SketchUp at the proposal stage to illustrate the major phasing and sequencing of the project. So we'll work out where the crane locations go, and we'll do this all to scale. We'll put in the hoarding and site trailers. We'll look at how deliveries are going to be delivered to the job site. We'll look at, we'll model out the major sequencing of where we're going to build and how we're going to build. So we use this as a tool to communicate to the client how we're going to execute. And this is like a multi-billion-dollar hospital in the Middle East. Just kind of a quick example. Now, the next D, I don't like this D vernacular that people use, but so 4D scheduling is the concept of taking your project schedule and linking it to your 3D model. So now each activity in your schedule is linked to the appropriate object in the model, and you can play a simulation of how that building is going to be built. And because it's linked, if you adjust your schedule, it adjusts the simulation. And you can actually go into this and stop it and review certain scenarios at certain points in time. So it can be a very effective tool for evaluating like what-if scenarios with project scheduling. And it's also a good tool to communicate to the client where you are in the progress of the building, or what's going to happen next, or communicating to the sub-trades that are actually working in the field. This is the Toronto South Detention Center, which is a project, a P3 project where we had precast, prefabricated cell blocks that were being delivered to the job site, then assembled. Whereas each one of those cell blocks was linked to the project schedule. 5D estimating is the concept of taking that 3D model that has all that information and all the quantity information in it, the project schedule, and then cost loading that so that now you have a system that you can go forward with through construction. So you can generate your earned value reports for billing purposes and illustrate to the client, this is where we are in construction, here's the 3D model, here's our project schedule, and here's our earned value report, and it's all one system that we manage going forward. We can also use the models for quantifying, say, concrete or other systems as the design evolves, and we can quickly review different quantities at different points in the design process and illustrate to the client, okay, this is why the cost of the building is escalating, because the structure is getting bigger at the base of the building. So we can do a quick comparison between 50% design development and 100% design development, and then show the client how it's evolved. So it's a good tool for managing cost through design. And then 6D is what they're throwing around to talk about facilities management. So if you hear these terms, that's what it's supposed to mean. But essentially, this is where the facilities management team can access the data for the building through the model. And I think this is a big area of improvement too. There's going to be a lot of software that emerge in this as time goes on. So everyone here probably, well, I hope you do, have the skills, like blueprint reading skills. Is obviously essential when you go into a construction site or you're dealing with anything in the industry. You need to be able to read blueprints. Now you're going to have to be able to review models. So what we're doing as a general contractor is we're maintaining a master coordination model in the field. So all this information that's constantly evolving, we're integrating that together and making that available on the job site, so anyone who comes to the job site can have it, or we can put it on an FTP site and you can download it and open it up on your own machine and walk through the building and look at systems. And so that's the master coordination model. So in this case, this was the waypoint example, just to give you an idea of the collaboration. So Canada Design was the architect, and they produced all the architectural systems. Stevenson Engineering did all of the structural concrete, structural steel engineering. EURA did all the mechanical systems. And when we moved into construction, TempCal did the sheet metal ductwork models. Kelson Mechanical did all the piping. Paul and Douglas did produce the sprinkler model, and Trussman Steel did all the structural steel. So we have multiple models that are being built concurrently and then integrated together and compared, and we're managing all these issues between all these different players.
So a question about that, like when you've got different suppliers and consultants working in parallel on the same building, you know, how are they gonna know where, like, if I'm the mechanical sub and I'm planning where I'm gonna put my duct, but that same week, you know, the structural supplier or consultant figuring out where he's gonna put his beam, right? Like, we're not gonna know until 2 weeks from now or a week from now that there's that
Yeah.
issue, right?
Well, you have to have a strategy, right? Like, there's different ways to manage it. What happens is the designers, they're producing the same thing. Like, the designer's going to produce a rough ductwork model that shows the sizing and the rough location. Then that gets refined as we go forward. So that's sort of like the plan. And then the subtrades produce content based on that plan. And then we're constantly monitoring it. You also kind of work out a strategy. Like, when we sit down, as we typically would, like with mechanical subtrades, we work out a strategy for each area of the building. We'll draw like a sketch, we'll select a section through the building and then show, okay, piping's going to go high, ductwork's going to go medium, sprinkler, and electrical.
Also, you have strategy.
Yeah, and then everyone kind of follows that, and you're eating the elephant one bite at a time, right? Like, these models are being produced a little bit at a time for each area of the building, and then we're collecting those models on a weekly basis, and then having a quick meeting to review where and how things are clashing in the building. So like paint and rebar are things that we typically rely on the subtrades to quantify, but now we can quickly understand the quantities and check the prices that we get back from the subtrades to make sure that they are appropriate against what our own quantities are. So here's the art gallery, just a quick example of prefabrication. So, yeah, sorry, go ahead.
Sorry, for the previous one, I think, when you guys go out to bid, for example, a paint bidder, do you give them that information, or is it for them to figure out and then you just check it? Because if you were to give them that information, does that make you kind of
responsible for the quantity? Yeah. No, we want the subtrades. The subtrades are taking on the risk, which means they have to come up with their own quantities, right? But we have our own quantities that we can check against their quantities to make sure that they're on target, like do logic tests. And plus, like, quantity is one thing, but the cost related to executing the work is totally different. Like, the cost to paint a baseboard is a lot less than the cost to paint, a ceiling, for example. But we're just looking at quantities. So the subtrade has to think, how am I going to set up to get 100 feet in the air to paint that ceiling, right? So there's still like a lot of logistics costs that we can't account for.
But then they can possibly come back and say, well, we did our pricing based on what you gave us, and if that was wrong, then we don't know.
Yeah, exactly. So we don't want to be in that situation. And in the UK, it's a little bit different. They provide the quantities and they put a price against the quantity, and the general contractor is 100% responsible. And in our industry in Canada, it may evolve that direction, but right now it's not. Anyway, so quick example of prefabrication. This is a Frank Gehry project. Frank Gehry's office supplied wireframes indicating the geometry in 3D, and those wireframes were part of the contract documents, so it's like a skeleton. So then we issued that wireframe geometry to the subtrades, and the subtrades produced the models and hung all the meat on the skeleton, if you will, and produced models and resubmitted those to us. And then they prefabricated all the elements and brought it to the job site and assembled it, and there's no manipulation of the field. So it's a very effective way of working. And there's big advantages from a schedule perspective over traditional construction. Traditional construction, everything is start to finish. You can't really start doing the drywall until the building's enclosed and you have your HVAC system running, so you have constant humidity. So you can only build so fast, right? But with prefabrication, you can build in a factory environment and deliver a whole room to the job site that's painted with tile and fixtures installed. So, in the Bow in Calgary, they're prefabricated 120 washroom units and delivered to the job site and installed them. So now, from a schedule perspective, you can start all that work concurrently. Instead of being start to finish, you can start everything start to start and build the building a lot faster. And if you can build faster, you reduce your financial costs for lending, and that is a big advantage, right? So from a mechanical perspective, you can do the same sort of thing. You can prefabricate corridor units that have all the mechanical systems in them, and then install those systems as a unit in the field. So it's a different way of working, but obviously to get to that point, you need to predetermine what you're going to build. You can't bring the raw material to the job site and install it. You have to predetermine, build a 3D model of what you're going to do, build it in a factory environment, and bring it to the job site. So another quick example for the AGO. We talked about wireframe. So this is the south. Well, we call it the Barnacles area. There's S101. But this is the stair on the back of the Art Gallery over above the Grange Park. And this is the wireframe geometry that was issued from the architect. And then these are the models that were produced by the subtrades that match that geometry, and they use these models to produce their documentation, their fabrication, and they controlled the fabrication and the installation using total stations and vector points to make sure that everything was perfect. So that's kind of a quick example of using geometry there's a 3D model to control geometry. Another kind of interesting thing that we're doing as a group is we're doing point cloud surveying. So like a total station is an instrument that sits on a tripod. You can shoot individual points and lay out those points exactly in the field. Point cloud surveying is similar, but instead of shooting one point at a time, it shoots 1,000,000 points in all directions. So now you can actually get a three-dimensional model of an interior space or an exterior facade of a building as a starting point for design or doing analysis. Say, here's the ACC and the Gardner Expressway. So we actually have to engineer a walkway that goes underneath the ACC and connects to the new building that we're constructing. And obviously having that exact geometry that we can bring into Revit or these other 3D programs gives us a firm, certain footing, a firm place to start the design process from.
So because once in one of our courses we saw this done, but from a plane.
Yeah.
It was for like a small city.
Yeah.
Now, if you want to get an actual topography of everything, you need to go to various points, right? That way any obstructions aren't right? You need to go to several points and then map that all together, right?
Yep.
Okay.
Yeah, the aerial point cloud is not as accurate, obviously because you're flying the plane, and it's plus or minus a meter, right?
Yeah.
They also have instruments that can mount to a vehicle, and that's plus or minus half a meter.
Right.
If you set up and have stationary points and then lock those points together with datums, you can get like 5 millimeters. So there's big improvements, obviously, but one costs more than the other. It takes a lot longer to collect the information using the stationary points.
Okay.
And there's a number of different instruments out there that have different ranges and different accuracies and different speeds, right? So we're using this Faro unit. It's about $55,000 and it's from Germany, and it scans 1,000,000 points in about 5 minutes in color, which is pretty nice. And that's great for interior spaces, and you can do exterior spaces, but it's limited for topography or like a 7-kilometer road, which we're doing some scanning like that, but we sub it out typically. So that's the process there. So that you have a building, you set up your scanner, like you said, you set up datum points, you process the information, and that produces a cloud. We can also put this on the internet, so you can go in through a portal, sign in, and go into that project and then walk around that building, similar to Google Street View. You can take measurements, so it's a pretty nice tool. I'll demonstrate that if I've got time. This is the Massey Hall. I don't think I've ever been to Massey Hall downtown Toronto, but pretty interesting scan. So, but difficult because it's a tight interior spaces. So to connect all those scans together and have it to be fully accurate, with 180 different scans is quite difficult. But again, we can take this and we can section it, we can export it, bring it into CAD systems, and then produce CAD work from it or produce 3D geometry from it.
So are all these softwares, are they compatible in between each other? Let's say Revit and AutoCAD, can they?
Yeah, you can bring, if you do a 2D drawing in AutoCAD, you can bring that into Revit and then build up from it. And there are different file formats. You can get the geometry out of different systems, but sometimes you lose the data. Like if you take like a Bentley model and convert it to a DWG and then bring that into Revit, you don't get any of the data. But if you go Bentley IFC to Revit, you get the data, right? So you just have, but
so there's
always kind of a way to get there, but you have to plan out how you're going to work through it. So there's a couple sections through the building there. We're using this for as-builting as well. So as we build the building, we can scan. So this is the Calgary Airport where we have in-floor heating. And one of the challenges we always have with construction is we might have to go back and core a hole for a sleeve for mechanical systems that we didn't anticipate. So if we have a 3D model of all the in-floor heating, we'll know where we can put that sleeve precisely, because we actually have all those 3D vector points that we can measure and make sure we're not going to hit anything when we go to core that hole. And it's also useful to the client long term because they'll know exactly where all the in-floor heating is if they ever have to do a renovation or run a conduit or whatever the case is. And again, we can take this and drop it into CAD, or we can go into Navisworks or other systems. Here's another quick example of from the art gallery. This is the wireframe for the feature stair. There's the steel. And the challenge with this job was that, obviously we're prefabricating chunks of this steel, very complex, in a factory environment. They're setting up jigs and welding it all together. And it's all full pen welds, so there's a lot of metallurgy stresses that occur when you heat up metal. It kind of pops and strains and stretches. So that you bring that to the job site, and you've got a bit of deflection with how the stair's been supported, and it's also, just the nature of the thing. It's complex to install it precisely. But we do have systems that have to go onto the building that are precise. We have a stainless steel cladding system. We have prefabricated curved glass that has to tuck in underneath that steel soffit, and a number of other systems from other subtrades. And we knew that that steel was at a tolerance, but we didn't know where or how much. So we were able to scan that and bring it in, put that point cloud over the steel model, and do a comparison to know exactly where it's off and how it's off, so that we can mitigate the issue without any cost to anyone or any delay. So just another way to use that point cloud information in a very proactive way to check the problem. So there, in this case, it was like a 3.5-inch deviation at the soffit, and we just worked out a strategy on adjusting the other systems that were coming to the job site, and adjusting the structural steel to a certain extent. And there's the finished product. If you're ever on the roof of the art gallery, you'd be able to see that. It's quite nice. So, this video doesn't work on my PowerPoint presentation. So here it is. I don't know if you guys have looked into this at all, but you can actually take an Xbox Connect and hack the firmware on it, and then use it as a scanner. So for like $69 on Craigslist, you can get a Connect and then use that to actually scan. And it works by infrared, so it's got a sensitive infrared light, and it collects with an infrared receiver. And the longer that you're scanning these objects, the smoother the point cloud gets on the object. So you can see that it won't be long until you have this kind of technology in your cell phone, so that you can actually produce a 3D model of an interior space, and then take measurements off that model, or export that into another CAD system. So it's evolving very fast. Actually, one of my guys in Vancouver, Omar, worked this out for us, but it's pretty neat. So there's these. There's some whole there. I think some grad students at MIT have also worked. They're kind of creating this as they go, right? So now they've got it worked out so that you can scan like a whole room. But the way that we're doing this here, you're kind of limited to a certain area. There's a lot of slides here. Yeah, so there's that's practical use of it. You can actually go and scan the conduit and insulation and studs from behind the wall. So we're doing a bit of this right now with the Faro to capture the as-built conditions as we build. But these kind of tools would be great to have, in your cell phone, so you can snap a 3D model of an as-built condition and then bring that into a 3D model for the owner to use long term. There's the superintendent. So I've got a few more minutes, so I'm going to show you. So we talked about having an online portal to access the point cloud. So this is the portal here. You essentially go in, you sign in, you pick the project that you want to access, and then we have like a street view type interface where you can actually zoom in. This is in plan view, so you're looking down on a scan. And you can actually go into this, and you can see where each one of these scans see what it sees. So you can see that there is a little bit of an opening here. Where the scanner doesn't see through walls, so you have to set up on all sides of things. And then if you double click on it, it brings you into that location. And you can look around. And then the point of this scan was to capture the existing conditions, because we wanted to give all these mechanical systems to the subtrades so they can either tie into those systems or engineer their work around the other work. And they can bring that into their 3D software. So the nice thing about this is, like, you know, you can go in and take a measurement very quickly. I don't know if that's a 2x4, I guess we'll see. So it's a nice tool for starting like a design, just to check what you're dealing with as a starting point. So here is, this is Navisworks. So this is a free viewer that you can download and install on your machine. And we have a licensed version of the software that we can actually integrate the models together, and then we publish a file that you can open up with Navisworks Freedom, and it's sort of like a locked file, like a PDF file that we can email around, so it makes it very lightweight, so people can then go in and access the model. And then this is organized. We set up a strategy on how we're going to organize the models. We usually organize a hospital by block or by floor, and then all the models that are produced, we make sure that they adhere to those standards so that we can have a model that is usable. You can create saved views in here, so if you found an issue, you save that view, and then you can go in and make notes on it, and then distribute that 3D file to the next person who needs that information.
What's the difference between this and Revit?
This is more like a review software, and it works well with all these different formats, and you can mark it up and save notes and track issues
So
using
you
this.
can't build the model.
No, you can't. You can do minor adjustments, but really you want to use, like this file tree right here is all the 3D files that we're bringing in from all the different companies, and they're all in different formats, and we convert it into this, and we track each one, and each one has a date stamp on it, and then we pull out the old one and the new one as we get it. So we use Revit, like the consultants using Revit, and they're publishing that and giving it to us, and we're putting it into this and checking.
So, question.
Yeah, go ahead.
So there must have been like, I would imagine a fair bit of pushback from people who just not too comfortable with this, and were kind of like used to the way things were working. Is that the case, or is that the case?
Yeah. It's a big cultural change, right? Anytime you're trying to change how we think or when we do things or what software we use, there's always pushback, right? So we have to kind of work through that. And the point of this is not, we're not producing models for academic reasons, right? We're producing them because we want to save people money, right? So the subtrade is bought into this and produced their content in a very detailed way. And they're like these hangers that they put into the piping. They're only putting that there because it saves them money and time in the field, because they know exactly where they're going to put their hangers. So now they can go in and maybe put anchors right in the formwork, so that they know exactly where they are. They can just tie into the master of the concrete support, rather than having to go up with a drill and do it to a healthy connector and into the underside of the slab, which is more work, right? So knowing what you're going to do in advance saves you time and money, and that's the point of doing these models. And what we're trying to do is facilitate between all the different parties that are producing this content. And that's not unlike what we would have done in 2D, except now we have a better tool where we can do more with less and work in a more precise way. Anyway, so that's 1 o'clock. We'll take a few questions, I guess, and you guys, I think the class ends at 1, right? Yeah. Okay, so, we can take a few questions, and if you guys want to split, whoever wants to stick around and talk, we'll do that.
For someone who's interested in this,
how do we go about learning about all these software? Like there's so many different
Yeah.
systems that are used.
Yeah, well, if you're going into the engineering field, I'd suggest you learn how to use Revit, and you can download a free version of that from the internet and just start playing with it. There's lots of tutorials, all sorts of resources online. There are classes you can take. I don't know if UT offers anything, but certainly George Brown does. And then you probably just learn by doing, right? Like once you get into the workforce, you'll learn on the job. With what we're doing here, we're integrating between all these different softwares. It's unique to the general contractor's role, so you can get exposed to that if you come work for us or another general contractor firm that's doing that. But it's just sort of like it's most like I learned through doing, like being in the field and working through all the problems. Right? Any other questions?
I'm sure it varies, but on average, how many people will work on a model?
Yeah, it definitely varies. Like on a small project, it might be like a handful of people. On a multi-million-dollar hospital, it might be like almost 100 different people working in different teams on different pieces of software, right? But you can definitely, the reason that the architects and engineers are switching to Revit is because they can do more with less. Instead of having a team of 10 drafters working in CAD, they can have 2 or 3 people working in Revit, and they can work at it more effectively and get more done and manage changes better. So it's helped a lot.
But the project scale on this has to be large in order for this to be profitable. Because if it's a small project, like for a GC to have a certain group of people producing these files,
Yeah.
is sort of extra work, right? So
Yes and no. I mean, if you're dealing with companies that would do this anyways, that's just how they work and it's easy. If it's a small project and we're dealing with small general contractors that don't have the capability, we might take a different approach where we model everything and give it to them, and then they pick up our work and run with it. They're still responsible for the end result, and they're still responsible for engineering things. But we might, on a McDonald's or the service center on the 401, model everything to the nth degree, and then give that to the subcontractor and say, here's our best work. It's for reference only. You can use this and go to CAD and finish the work, or use at your own risk, essentially.
I guess it's only big GCs that do this.
Yes and no. I mean, there is examples of smaller general contractors that are picking up the tools.
Oh, yeah?
I think it'll be easier. The more people in the workforce that know how to use the system, it'll be easier to hire people. It'll become like CAD. Anyways, thank you very much.